So in the last lecture, we solved the first sum on heat balance sheet. In this video, we will be solving the second sum on heat balance sheet. Okay. In this sum, I will be going a little bit faster because I expect that you should see the first heat balance sheet sum completely. Then you will get what all we have to do, right? So again, this is another question which is quite similar to the first one. What are the things that they have given us? They have given us that it is a single cylinder engine. It is a 4-stroke oil engine. The following observations were recorded. They have given us the bore, they have given us the stroke, they have given us the duration of test, 60 minutes. So 60 minutes is what? 60 minutes is 1 hour, right? They have given us the fuel consumption, they have given us the fuel calorific value, net brake load, indicated mean effective pressure, brake drum diameter, right? Brake drum diameter means what? It is a rope brake dynamometer. Also, they have given us the diameter of the brake drum. But in this case, see, they haven't given us the diameter of the rope. When I was teaching you rope brake dynamometer, I told you it is possible that sometimes they give you the diameter of the rope and sometimes they do not give you the diameter of the rope. If the diameter of the rope is not given, do not worry, assume the diameter of rope to be 0, right? And use the formula d plus 2d divided by 2. They have given us the cooling water flow rate 500 kg. They have given us the temperature of exhaust gases 300 degrees Celsius. They have given us the cooling water temperature rise which is 40 degrees Celsius. The amount of air consumed is 300 kg. They have given us the exhaust specific heat capacity, right? And they have given us the room temperature 25 degrees Celsius. Again, we have to find the same things: mechanical efficiency, indicated thermal efficiency, and brake thermal efficiency. So mechanical efficiency is what? Brake power upon indicated power. Indicated thermal efficiency is what? Indicated power upon thermal power. And brake thermal efficiency is what? Brake power upon thermal power. So basically we again have to find the same three things: brake power, indicated power, and thermal power. And then we have to draw the heat balance sheet on minute basis. What I would suggest to all of you is to first stop this video right now and solve this sum on your own. Okay, see, it is same as the previous sum. I have just put this sum in here so that you can get to practice. This is same as the previous sum, so you can practice this sum and then check this video to see if your answer is correct, right? So let us start off. So this is the given data. Again over here I have done the same thing. I have calculated the angular velocity. Angular velocity is omega. It is what? 2 pi n upon 60. They have directly given us the engine RPM. What is the engine RPM? Sorry, I forgot to write it over here. They have given us the engine RPM in the sum itself. Okay, sorry, I was forgot to write it over here in the given data. But the engine RPM is given as 220. Okay, so from this we have the angular velocity of 23.04 radian per second. We know that K is 0.5 because engine is 4-stroke engine. They have given us number of cylinder is 1. But see, in this case, in the last sum, they had given us the net brake load in terms of what? Newton. Here they have given us net brake load in terms of what? Kg. When I was teaching you dynamometer, I told you that the value of load should always be in Newton. So to convert from kg to Newton, you multiply it by acceleration due to gravity, right? So we get 130 into 9.81 is equal to 1275.3 Newton. That is your brake load. What is the dynamometer radius? This time d plus 2d divided by 2. They haven't given us the value of this d. So this d is what? This d is 0. So it is only d divided by 2, right? So it is 0.825 meter, right? So to find the efficiencies, we have to find these three powers: thermal power, brake power, and indicated power. What is the formula of thermal power? Thermal power is what? Fuel flow rate into calorific value. So that is what we have done. Fuel flow rate into calorific value. We know the fuel flow rate is 7 kg per hour. So again I have done what? Fuel flow rate into the calorific value. I have found it per hour, right? This is per hour. Then I am dividing it by 3600 to convert per hour into per second, right? So it is 87500 watt. Joule per second is watt, right? And converting it into kilowatt, we get 87.5 kilowatt. So that is my thermal power. Again, I have to find indicated power. For indicated power, what have they given us? See, for indicated power, they have given me indicated mean effective pressure, right? They have given me indicated mean effective pressure. I will use the formula IP is equal to Planck upon 60 into number of cylinders. Value of indicated mean effective pressure is this much, right? What is the stroke length? They have given me the stroke length. They have given me the bore diameter. Substituted those values and I got P into L into A. What is RPM? 220. It is given in the sum. I have just forgotten to write it in the given data. And what is K? K is 0.5. Why is it 0.5? Because it is a 4-stroke engine. See, K is a constant. It is 0.5 for 4-stroke engine. It is 1 for 2-stroke engine. Into number of cylinders. Number of cylinder is 1. So substituting all these values, I get the value of indicated power. I have the value of thermal power. I have the value of indicated power. Now I need to find the value of brake power. To find the value of brake power, what is the formula of brake power? Brake torque into angular velocity. And what is the formula of brake torque? Brake torque is what? Brake load into dynamometer radius. So I already calculated the brake load. How did I calculate the brake load? Because they have given us the net load, which is 130 kg. Because it is in kg and I have to convert it into Newton, I am going to do what? Multiply it by 9.81. So I have it in Newton and multiply it by the dynamometer radius. What is dynamometer radius? D by 2, which is 0.825. So I get the brake torque, right? So brake torque into angular velocity will give me the brake power, right? So this is my brake power, 24.24 kilowatt. Now that I know the values of the brake power, I know the values of brake power, indicated power and thermal power. I can substitute these three powers in these three equations. Mechanical efficiency is BP upon IP. So I get 70.85. Indicated thermal efficiency is what? IP upon TP. So I get 39.10. And brake thermal efficiency is BP upon TP. So I get this 27.7%, right? So this is how these efficiencies are calculated. See, I went a bit fast because this has been covered in the previous videos also. Okay, so you can check that out if you haven't understood it, right? Then what they have told us that we have to draw the heat balance sheet on minute basis. I told you, you have to remember this format by heart, right? This format should be known to you. You just have to fill in the values. Out of these values, what are, we know the thermal power. We know thermal power in per second. We will multiply it by 60 and we will get thermal power in per minute. Similarly, we know brake power in per second. We will multiply brake power in per second by 60 and we will get brake power per minute. To calculate heat loss to exhaust gases, what are we going to do? MC delta T exhaust gases. To find the heat loss to coolant, what are we going to do? MC delta T coolant. And to find the unaccounted heat losses, what are we going to do? Subtract these three things from this. Subtract these three things from this and we will get the unaccounted heat losses, right? So that is what we are going to do. So first of all, to find thermal power, this is per second. We multiplied it by 60 and converted it into per minute. Similarly, brake power, this is per second. We multiplied by 60 and convert it into per minute. What is the heat loss to exhaust gases? Heat loss to exhaust gases is what? MC delta T exhaust gases. What is the mass of exhaust gases? What are exhaust gases made up of? Exhaust gases are made up of fuel and exhaust gases are made up of air. So fuel plus air is equal to exhaust gases. So I am really sorry. I just copied it from the previous sum. It should be 7 plus 300. Okay. So that is what? 7 plus 300. So 307 kg per hour. That is 5.117 kg per minute. So you know the value of M. They have directly given us the specific heat capacity of exhaust gases, which is 1.004, and they have given us the delta T. Delta T, what is the change in temperature of the exhaust gases? The change in temperature of the exhaust gases is temperature of exhaust gases minus room temperature, right? Where is the room temperature? Over here. So what is delta T of exhaust gases? Temperature of exhaust gases minus room temperature. So 300 minus 25, which is what? 275. Right? So substituting these all values over here, we will get Q is equal to MC delta T and that will be this much. In this case, see, I have kept the mass flow rate of exhaust gases in minute only, right? So I can get the value directly in kilojoule per min. So after finding the heat loss to exhaust gases, the next thing that I have to find is heat loss to coolant. Again, the formula is same, Q is equal to mc delta T. What is the mass flow rate of coolant? They have given 500 kg per hour, converted it into kg per minute by dividing it by 60. The specific heat capacity of water should be known to you, 4.18 kilojoule per kg Kelvin. See, specific heat capacity of water will not be given to you in the exam. You should know it by heart. That specific heat capacity of water is 4.18 kilojoule per kg Kelvin. And what is the delta T? Delta T has been directly given to us. See over here, delta T, change in cooling water temperature, rise in cooling water temperature is given to us, 40 degrees Celsius. So substituting these values, Q is equal to mc delta T, we get what is the heat loss to the coolant, which is 1393.3 kilojoule per minute, right? Again, so we have found out all these values. See, what are the values that we have found out? We have found out this value, we have found out this, this and this. What are unaccounted heat losses? Unaccounted heat losses are this term minus the sum of these three terms, right? That is your unaccounted heat losses. So how are we going to find unaccounted heat losses? Thermal power minus summation of output heat energy. So 5250 minus, this is your brake power, this is the heat loss to exhaust gases, this is the heat loss to coolant. So these are your unaccounted heat losses. Now substituting all these values over here, we are just finding the percentages, right? What am I doing in this step? In this step, I am doing this, finding these percentage values. Okay, so that is what you do, and with this you can complete your heat balance sheet, right? See, I went fast because I am telling you I have explained all this in the previous video. This is the same sum, literally the same sum with just the values changed. So you can try this on your own. It is quite simple. And with this I complete the question number 2. Similarly, I will solve a few more examples after this. The next example will be a bit different. So check that out. Okay, thank you.